If you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today we will be talking about domain, range and graph of Cos X and Cos Inverse X. So for that, let's take a unit circle where the coordinates on axes are 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Now let's take the function fx is equals to cos x. So for the domain of cos x, so as we can see here, x could be any real number. So domain of this function will be any real number from minus infinity to plus infinity. So it is x and x belongs to any real number or minus infinity to plus infinity. So that's the domain of cos x. Now the range, for the range, as we can see on this unit circle, the maximum value for cos is 1 and the minimum value is minus 1. So the range for cos x is from minus 1 to 1. So the domain is minus infinity to plus infinity and the range is from minus 1 to 1. So now let's graph fx is equals to cos x, whose domain is from minus infinity to plus infinity and range is between minus 1 and 1. Now in unit circle we can see that at 0 degree, pi by 2, pi and 3 pi by 2, cos is 1, 0, minus 1 and 0 respectively. So we can plot these points for cos x. So at 0 it is 1, at pi by 2 it is 0, at 3 pi by 2 it is 0 and at 2 pi it will be 1 again. So for cos x we will get this curve whose domain is minus infinity to plus infinity and maximum point at 1 and minimum point at minus 1. So now if we do the horizontal line test for this curve, then it will fail because it is intersecting with the curve at more than one point. So this function fails the horizontal line test. As we already know that for a function to have an inverse, it must pass the horizontal line test. So there will be no inverse for this function until we reduce the domain of cos x. So to have an inverse for cos x, we must reduce the domain of cos x. Now instead of minus infinity to plus infinity, let's restrict its domain between 0 and pi. And between this interval, let's do the horizontal line test again and we can see that this time it will pass the test because it is intersecting at only one point. So it passes the test between 0 and pi. So for inverse, domain of cos x should be reduced to 0 to pi. So for the function fx is equals to cos x, domain is minus infinity to plus infinity and range is between minus 1 and plus 1. Now let's find out the domain and range for cos inverse x. So the restricted domain of cos x will be the range for cos inverse x, and the range of cos x will be the domain of cos inverse x. So the domain of cos inverse x is -1 to +1, and the restricted domain for cos x was from 0 to pi. So the range for cos inverse x will be 0 to pi. Between this range, cos x will have an inverse. Now let's graph y or fx is equals to cos inverse x, whose domain is -1 to +1 and range is between 0 and pi. So the inverse cosine function switches the coordinates of the restricted function. So now x is y and y is x, and the coordinates are 1 0 0 pi by 2 -1 pi and so on. And as we can see here, between the range 0 and pi, it will pass the horizontal line test. So the cos x will have an inverse between this range, and this range is called the principal value. So the function fx is equals to cos x will have an inverse function between this range, that is 0 and pi. Also, we can graph cos inverse x by reflecting the graph of y is equals to cos x in the line y is equals to x by restricting the range of values of the reflected curve.